Have you ever wondered how passenger aircrafts are manufactured? The process is a marvel of engineering, intricately weaving together the threads of design, material selection, and precise assembly. Aircraft manufacturing is a complex symphony of precision and innovation where every step is critical to the end result. It's a world where fractions of an inch make all the difference, and where the smallest error can have far-reaching consequences. Each component, from the largest wing to the smallest bolt, plays a vital role in ensuring the safety and efficiency of the final product. The process is a testament to human ingenuity, combining cutting-edge technology with the timeless principles of engineering to create machines that defy gravity itself. This is not just about building machines, it's about pushing the boundaries of what's possible and creating something that's more than the sum of its parts. Stay with us as we delve into the fascinating step-by-step process of passenger aircraft manufacturing. Aircraft manufacturing starts long before the assembly line with the design phase. Imagine a blank canvas. It's on this untouched surface that engineers start sketching the first lines of what will eventually become a colossal, sky-conquering marvel. The design phase is the cornerstone of aircraft manufacturing, the place where ideas take flight, quite literally. Engineers, armed with decades of aviation knowledge and cutting-edge technology, begin by creating a detailed three-dimensional model of the aircraft. They employ a tool that's revolutionized the industry, computer-aided design software, or CAD for short. This remarkable technology allows them to visualize every minor detail, from the curvature of the wings to the placement of the engines, with precision that would make even Da Vinci envious. Now, as they sketch and model, three crucial considerations guide their every stroke: aerodynamics, fuel efficiency, and passenger comfort. Aerodynamics, the study of how air moves around objects, is a fundamental aspect of aircraft design. It's all about crafting lines and shapes that will allow the aircraft to slice through the atmosphere with the least resistance, like a hot knife through butter. The better the aerodynamics, the smoother and faster the flight. Fuel efficiency is another vital cog in the design machine. An aircraft that guzzles fuel isn't just costly to operate, it's also detrimental to our environment. Engineers constantly innovate, seeking ways to make aircraft more fuel efficient, thus reducing operating costs and carbon emissions. And let's not forget passenger comfort. The engineers must strike a delicate balance between maximizing passenger space and maintaining the aircraft's overall efficiency and performance. They meticulously design the cabin layout, seating arrangement, and even the position of windows to ensure a comfortable and enjoyable flight experience for passengers. The design phase is a complex dance of science, engineering, and artistry. Each step meticulously choreographed to create a machine that's as beautiful as it is functional. Once the design is approved, it's time to move to the next phase: material selection. The choice of materials in aircraft manufacturing is a delicate balance between strength, weight, and cost. It's like a complex dance where every step is calculated for precision and efficiency. So let's dive into the world of materials that make flight possible. First on the list is aluminum, a material that has been used in aircraft manufacturing for decades. It's light, it's strong, and it's relatively inexpensive, making it an excellent choice for large portions of the aircraft's structure. But it's not just about the weight and cost. Aluminium is also resistant to corrosion, which is crucial when you consider that these aircraft will be exposed to all sorts of weather conditions. Next, we have titanium. This material is as strong as steel but weighs significantly less. It's used in parts of the aircraft that require high strength, like the engines and landing gear. Titanium is also highly resistant to heat and corrosion, which lends itself perfectly to the harsh environments of high-speed travel. But the material of the future, and increasingly the present, is composites. These are materials made from two or more different types of materials, such as carbon fiber and epoxy resin, that when combined create a material that's stronger and lighter than its individual components. Composites are increasingly being used in aircraft manufacturing because they offer superior strength and stiffness, while also providing weight savings. They're particularly useful in the wings and fuselage, where weight reduction can lead to significant fuel savings. Each of these materials has its own strengths and weaknesses, and the key to successful aircraft manufacturing is to use each of them where they're most effective. It's a balancing act, trying to create an aircraft that's strong enough to withstand the rigors of flight, light enough to be fuel efficient, and affordable enough to be commercially viable. Now that we have our design and materials, it's time to start building. The manufacturing process of an aircraft is a meticulous task that requires precision and attention to detail. Diving headfirst into the manufacturing process, let's begin with the fuselage. The fuselage, or the aircraft's main body, is an engineering marvel in itself. It's primarily constructed from high-strength aluminum alloys, crafted into a cylindrical shape to withstand the pressures of flight. The manufacturing of the fuselage involves forming, cutting, and assembling large aluminum sheets. These sheets are first shaped by a process known as stretch forming, then cut into precise shapes by automated machines. Once cut, these pieces are fastened together, using thousands of rivets and fasteners, creating the basic structure of the fuselage. Next on the list are the wings. Wings are the heart of an airplane, providing it with the lift it needs to soar through the skies. They're typically made from the same high-strength aluminum as the fuselage, although modern aircraft often incorporate composite materials for their superior strength-to-weight ratio. Wing manufacturing begins with the assembly of the internal structure, known as the wing box, which includes the spars and ribs. After this, the skin of the wing is added, followed by the installation of the flaps and ailerons, which are critical for controlling the aircraft's movement. Now let's turn our attention to the tail, or the empennage. The tail consists of two main parts, the vertical stabilizer or fin, and the horizontal stabilizer. These components help maintain the aircraft's stability and control its direction during flight. Similar to the wings, the tail is also constructed from sturdy aluminum or composite materials. It's built in sections with the internal structure assembled first, followed by the addition of the outer skin. Once completed, control surfaces like the rudder and elevators are fitted. The last major component we'll discuss is the engine. Arguably the most complex part of an aircraft, the engine is a feat of engineering that's made up of thousands of individual parts. Manufactured separately, these parts include the fan, compressor, combustor, turbine, and exhaust. Each part is precision engineered and then assembled in a specific order to form the complete engine. The engines are then mounted onto the wings or the fuselage, depending on the aircraft's design. With all these parts made separately, you might be wondering how they come together to form a complete aircraft. Well, that's where the final assembly line comes in. This is where the fuselage, wings, tail, and engines are brought together and assembled into a complete aircraft. The process starts with the joining of the fuselage sections, followed by the attachment of the wings. Once this is done, the tail is fitted, and then the engines are mounted. This process requires a high level of precision, as even the smallest misalignment can have serious repercussions. But the assembly of these major components is just part of the story. There's a multitude of other parts, including the landing gear, the seats, the cockpit instruments, and the in-flight entertainment system, all of which need to be installed. And let's not forget the miles and miles of wiring and piping that run throughout the aircraft, connecting everything together. The manufacturing process of an aircraft is a symphony of engineering, where each part plays its role to create a machine that's more than the sum of its parts. It's a process that takes months, sometimes years to complete, but the end result is a marvel of modern technology, capable of transporting hundreds of people across the globe at incredible speeds. With the main body of the aircraft assembled, it's time to move on to the next stage, systems installation. Systems installation is where the aircraft starts to come to life. It's like the nervous system of a living organism, connecting different parts and enabling them to communicate and function in harmony. First up is the electrical system. This is the lifeblood of the aircraft, powering everything from the cockpit instruments to the in-flight entertainment. Without electricity, an airplane is just a giant metal bird that can't fly. The electrical system includes generators, batteries, and wiring that run throughout the plane, providing power to all the necessary components. Next, we have the hydraulic system. This robust network of pumps, reservoirs, and high-pressure tubes is responsible for controlling the aircraft's major mechanical movements. Think of it as the muscles of the plane, powering the flaps, landing gear, and brakes. Without hydraulics, controlling an aircraft would be like trying to steer a ship with a toothpick. Then comes the avionics. This is the brain of the operation, handling navigation, communications, and flight control systems. It's a complex web of computers and software that processes vast amounts of real-time data, allowing pilots to make informed decisions during flight. Avionics systems also include the autopilot, weather radar, and collision avoidance systems, all designed to make air travel as safe and efficient as possible. It's important to note that these systems aren't just thrown together. They're meticulously designed and installed to work in harmony, each one complementing and supporting the others. The electrical system powers the avionics control the hydraulics, and the hydraulics move the plane. Every wire, every tube, every microchip is purposely placed and carefully installed. It's a symphony of engineering, a testament to human ingenuity, and a marvel of modern technology. But as intricate and impressive as these systems are, they're just one piece of the puzzle. With the systems installed, the aircraft is almost ready. But there's one last crucial step: testing. No aircraft leaves the factory without undergoing rigorous testing. This is a golden rule in the aircraft manufacturing industry, and for good reason. Passenger safety is paramount, and every plane must prove its worth before it is allowed to take to the skies. Let's delve into the types of tests an aircraft must pass. First up is engine testing. This involves running the engines under various conditions to ensure they can withstand the rigors of flight. The engines are tested for power, performance, and efficiency, operating at different speeds and under different loads. They're even tested under extreme weather conditions to make sure they'll perform when it matters most. Next, we have flight tests. This is where the aircraft takes its maiden voyage. During this phase, test pilots put the plane through its paces, checking the handling, responsiveness, and overall performance. They perform maneuvers that push the aircraft's limits, testing the stability and control. This is a critical phase as it provides valuable feedback about the aircraft's flight characteristics. Then come the safety tests. These are perhaps the most critical of all. Here, the aircraft's safety systems are put to the test. The emergency evacuation systems, fire suppression systems, and even the seat belts are all scrutinized. The aircraft must demonstrate that it can handle emergency situations and keep passengers safe. Parallel to these tests is the process of quality assurance, a blanket term that covers all the activities to ensure the aircraft meets the required standards.